A video on discrete versus continuous functions. You do not have a set of C-scope notes for these. So you're going to have to do this on your own paper. I've already talked a little bit about this. Let's come back and review. Discrete functions. Should be an R. Consist only of points. That are not connected. Another way of looking at these is that all values between your discrete points will not occur. Okay, so a continuous function then is normally, well, actually, they will come from equations primarily. Values are connected. And all values between table values from the calculator will occur. So let's look at some possibilities, some examples of discrete functions. Now you can get these from equations, but primarily they're not. Discrete functions occur obviously when you're only given points. Discrete functions can also occur even with an equation when you're dealing with numbers of things. That are integers. An example of this would be number of people. Anytime you're dealing with number of people, you tend to be dealing with discrete functions. You can have a partial number of people. Another example would be, say you found a Coke machine and it costs 75 cents per Coke. Okay? So one Coke is going to be 75 cents. Two is going to be $1.50. Three is going to be $2.25, and on and on and on and on. This is discrete because only multiples of 75 cents are possible. Okay, so we look at graphs. Discrete functions are going to look like this. They're just separate points. So this would be discrete. Continuous functions are going to look like this. Okay, I forgot to mention, but this is good. You can also get a discrete function for instance, even if you're given an equation Okay, first time you take a look at that, you'd be tempted to say, okay, this is continuous, but they've limited our domain. It will be x will be equal to -2, 0, 2, and 4. Now, because my domain is discrete, it is only those 4 points. That's going to make my function discrete because my domain into the equation is discrete also. Okay, so let's take a look at how you're actually going to deal with this thing and work with it. So the first thing we know is we've got an f of x. And here it falls under the general category on the work you're going to do, which is go graph and classify. So on this one, we'll classify it as discrete because the domain is discrete. Okay, now we have to graph it. But all we've got are x values, so we need to find our y. You get that by plugging in up here. So we get f of -2 is going to equal to 1/2 of -2 plus 1, which is going to equal -1 plus 1, which is 0. Then I'm going to need to get f of 0, and I'm getting this by plugging these numbers in for x, is 1/2 of 0 plus 1, which is 1. F of 2 is going to be 1/2 of 2 plus 1, which is 1 plus 1, which is 2. And then f of 4 is going to be 1/2 of 4 plus 1. Half of 4 is 2 plus 1, gives me 3. So if you graph this thing, you now have 4 different sets of points. Okay, so I have -2, which is this, 0, which is my function value. Then I'm going to have 0, 1, 2, 2, and 4, 3. And then we plot these things. So I'm going to have -2, 0, 0, 1, 2, 2, and 4, 3. And we don't connect these because this is discrete. So there's your graph of it. Okay, the next one I'm going to deal with, we're going to deal with the same equation, which is f of x equals 1/2 x plus 1. But our domain is going to be x is bigger than or equal to -3. And what this means is that all x values bigger than or equal to -3 are possible. Okay, which makes this continuous because all values are possible as long as they're bigger than this guy. Okay, so what we do on this one then, since I know it's going to be bigger than -3, my function value is also going to have to be bigger than -3. So I'm going to find what the function is at -3. So it's 1/2 of -3 plus 1. This becomes -1.5 plus 1, which is 1/2. So my function value then is going to have to be bigger than or equal to negative 1/2. And when you graph this, I'm going to go to -3, negative 1/2. Okay, I know I've got a slope, so I rise 1, run 2, I go through 1. So there is my function. You notice it doesn't go down over here because it's not defined down there. Let's take a look at one more example. This is from my word problem. Your cell phone company charges $25 per month. So even if you don't use it, you do that one. Plus 3 cents per minute, or part of a minute. And $1.25 per megabyte of data or part of a megabyte. Download. Okay, well, first blush, look at this, you think, man, if this is your plan, you're dumb. Go to someone else. But let's assume you're too lazy to do it, so this is your plan. Okay, so they're going to charge you $25 per month, so your dollars going to equal to 25 plus, now, 3 cents per minute. So minute, is going to be minutes called. And D is going to be data. Now if you look at that, it's per minute or part of a minute. So if you talk for 1 minute and 1 second, they're going to charge you for 2 minutes. So in other words, you're never going to get 1.1, 1.2, you're either going to get 1, 2, 3, 4, and on up, which makes this discrete. It's going, now, it's come down per megabyte or part of a megabyte, okay? So you download 1.01 megabytes, they're going to charge you for 2 megabytes of data. So this is also discrete. Because both of these are discrete, our resultant equation will be discrete. So it's by 03M plus 1.25 D. And let's get an example of just what this is going to look like. You talked 132.5 minutes. This is in a month, so it's probably not a girl. And downloaded 13.1 megabytes of data. And you want to figure what your charge is going to be that month. Because you know if you go too much, mom and dad are going to take your phone away from you. Okay, so what we do then is we're going to go in and take a look. So M, you notice you talked part of a minute, but because you went over, it's going to be 133 minutes. And D is going to be 14 megabytes. And again, just because you went over, they're going to round it up. And now you can plug it into this thing, and I'm not going to do the arithmetic, but it will be $25 plus 0.03 times 133 plus 1.25 times 14. And again, this is discrete, and you can actually make a graph by plugging in different numbers for these things.